everyone. In this video, we are going to learn what is a derivative of composite function. Starting with the function, suppose we have a multivariable function that is depending upon two variables x and y. And now suppose these two functions are further depends upon some independent variable t. It means if we are taking the function z as function of x and y and x is depending upon t by this form and y with this. In this case, this function becomes as a function. Inside there is another function and second pair is also another function. So whenever we have a function composed with another function, that is called as a composite function. Means inside a function there is another function. Now in this case, how to find the derivative? That is again challenging. In this video, we are going to learn how to find the derivative of such functions. Here we have considered the three cases. The first case is z function is there that is depending upon two variables x and y, and further these x and y variable is depending upon only single variable t. So ultimately this z is depending upon t. Means when you find the derivative, we can find the derivative of z with respect to t. Whereas in the case 2, z is depending upon two variables x and y, and these x and y are further depending upon the two variables u and v. In this case, the z is depending upon u as well as v, and when you find the derivative of z with respect to u, that will get converted into partial derivative because it is depending upon more than one variable. And when you find the derivative of z with respect to v, again it is a partial derivative. Whereas in the case number 3, we have taken a z function that is depending upon one variable x, and this x is depending upon two variables u and v. Again in this case, z is depending upon two variables u and v finally. It means we can find the derivative of z with respect to u and v, but they are partial derivatives. Now the point is how to evaluate these derivatives. So when you need to find the derivative of z with respect to t, first we need to take with respect to x and y and then with respect to t. So on this case, when you take the derivative of z with respect to x, that will be partial derivative of z with respect to x because it is depending upon two variables. Even in this case, it is a partial derivative of z with respect to y. Now when you take the derivative of x or y with respect to t, it is an exact derivative. Why? Because x and y are the function of only one single independent variable. So it means in this case we will take the exact derivative dx by dt and here dy by dt. Now how to write the chain rule? So we will take these two terms in a product, these two terms in a product, but add these two. That is derivative of z with respect to t is equal to partial derivative of z with respect to x into dx by dt plus partial derivative of z with respect to y into dy by dt. The same rule we will follow in a case 2 and 3. In case 2, when you take the derivative of z with respect to x and y, it will be partial derivative as it is depending upon more than one variable. Same in this case, it is a partial derivative. Now, we need to take the derivative of x with respect to u as well as v according to the two different cases. So when you take the derivative with respect to u, again it is a partial derivative because x is depending upon two variables. So partial derivative of x with respect to u, or we will take partial derivative of x with respect to v. In this case, partial derivative of y with respect to u, or we will use partial derivative of y with respect to v. There is a no interlinked between u and v. They are the independent variables. So either we will take this term or this term as per the requirement. Like in this case, we need a partial derivative with respect to u. Means we don't need a partial derivative with respect to v. So we will not use this term and this. In this case, the chain rule is partial derivative of z with respect to x into partial derivative of x with respect to u plus on this side partial derivative of z with respect to y, then y with respect to u. Similarly, evaluate the partial derivative of z with respect to v. So for that we will take the partial derivative of z with respect to x into x with respect to v plus partial derivative of z with respect to y into partial derivative of y with respect to v. In case 3, we need to take the derivative of z with respect to u. Now, ultimately, z is depending upon two variables, that is a partial derivative. Now, how to evaluate this? In order to start from z to reach at a u, so first we need to take the derivative with respect to x, then with the respect to u. When you take the derivative with respect to x, in that case, it is the exact derivative dz by dx because it is depending upon single variable. Now this variable is depending upon further two variables. In that case, we will convert this into the partial. Here we have dz by dx into partial derivative of x with respect to u. That's all about this one. There's no need to add something because we have only one way to approach at u. In this case, we can either use this way or this, and even in this case, this way or this. Now, to find the derivative with respect to v, we will first take the derivative with respect to x, that is the dz by dx into partial derivative of x with respect to v. This is how we can write the derivative of composite function, but this rule is called as a chain rule. Here we have taken the first example that we need to find the derivative of w with respect to t, and this w is depending upon x, y and z. Further, x is equal to cos t, y is equal to log of t plus 1 and z is equal to e raised to power t. It means x, y, z are depending upon t. And if you construct the tree form in this case, we have w is depending upon three variables x, y, z, and further these three variables are depending upon t. We need to find the derivative of w with respect to t. You can check it. This w is depending upon single variable at last. Therefore, we can find the exact derivative of w with respect to t. In this case, we will use the chain rule. According to the chain rule, first we will take the derivative with respect to x, and that will be the partial derivative. As it is depending upon more than one variable, into we need to take the derivative of x with respect to t, and that will be the exact derivative of x with respect to t as it is depending upon only single variable, plus then we will take the derivative of w with respect to y, and that is a partial derivative of w with respect to y into exact derivative of y with respect to t as it is only depending upon single variable, plus partial derivative of w with respect to z into derivative of z with respect to t, that is exact derivative of z with respect to t. This is equal to partial derivative of w with respect to x, means we need to keep y and z as a constant. This is equal to twice of x into Derivative of x with respect to t, that is a cos t derivative with respect to t is minus sin t, plus partial derivative of w with respect to y means x and z is constant and the derivative is 2y into derivative of y with respect to t is, that is a log derivative is 1 by t plus 1 into the derivative of the internal term with respect to t is 1 plus partial derivative of w with respect to z is 2z into derivative of z with respect to t, that is e raised to power t. Simplified form in this case is minus twice of x sin t plus 2y by t plus 1 plus 2z into e raised to power t. The question is find the derivative of w with respect to t at t is equal to 0. Before substituting t is equal to 0, first observe the derivative. In this case, the derivative is depending upon x, t, y as well as a z. What you can do, either you can substitute the value of x, y, z and after that substitute the value of t, or you can calculate at t is equal to 0. The value of x is cos 0, 1. The value of y is log 0 plus 1, that is a log 1 and log 1 is 0 and z is equal to e raised to power 0 is 1. Now substitute all these four values in this case. We have minus 2 times of 1 sine 0, 0 plus twice of y as a 0, 0 plus 1 plus 2 times of 1 into e raised to power t is 1. This is equal to 2. Basically, this is the derivative of w with respect to t at t is equal to 0. In this case, I have written a type 1. Why type 1? This is the first type of a question we are having where the value of w is explicitly represented in form of x, y, z and further x, y, z are given to you. Sometimes this function is not exactly defined. In that case, we will call it as a type 2 question. For example, this is a type 2 question. Why? Because in this case, z is depending upon two variables x and y and x is depending upon two variables u and v. Even in this case, y is depending upon u and v. But the value of function is not given to you. In previous case, we have the function value in an explicit form, but here we need to take this function as it is. Again, we will apply the chain rule in order to solve this question as it requires the function derivative with respect to u as well as the function derivative with respect to v. As in this case, the function is depending upon two variables x and y and x and y are further depending upon two variables u and v. As per the requirement, we need the partial derivative of function with respect to u, that is evaluated as derivative of function with respect to x, but that is a partial derivative, into partial derivative of x with respect to u plus partial derivative of a function with respect to y into partial derivative of y with respect to u. This is calculated as, now what is the partial derivative of function with respect to x? As this function is not given to you, we will keep this term as it is, or we can write this is more simplified form as a fx into partial derivative of x with respect to u, that is twice of e raised to power 2u, but this term is 0 as it is depending upon v, not on a u, plus partial derivative of function with respect to y. As the function is not given to you, we will keep this function as it is, into derivative of y with respect to u minus twice of e raised to power minus 2u. This is equal to twice of e raised to power 2u into fx, negative sign of 2 e raised to power minus 2u fy. That is a partial derivative with respect to y. Similarly, evaluate the partial derivative of function with respect to v. This is calculated as partial derivative of function with respect to x into partial derivative of x with respect to v plus partial derivative of function with respect to y into y with respect to v. This is equal to, as this function is not given to you, we will keep it as it is, into partial derivative of x with respect to v. So this term is 0. Its derivative with respect to v is minus twice of e raised to power minus 2 times of v, plus this function is as it is, as the function is not given to you, into partial derivative of y with respect to v, that is twice of e raised to power 2v. Substitute these terms. In this case, we need the partial derivative of function with respect to u minus partial derivative of function with respect to v. This is equal to twice of e raised to power 2u partial derivative with respect to x minus twice of e raised to power 2u partial derivative with respect to y minus negative sign of this one, that is negative negative is a positive, twice of e raised to power minus 2v partial derivative with respect to x, negative of this one is minus 2 times of partial derivative with respect to y into e raised to power 2v. Simplify this, we can take 2 outside, collect these two terms. Coefficient of partial derivative of x are e raised to power 2u plus e raised to power minus 2v. Then the coefficient of partial derivative with respect to y, that 2 is already taken outside. We have minus e raised to power minus 2u. In this case, minus e raised to power 2v. This is equal to twice of partial derivative with respect to x. This term is equal to x. So we can write into x. Here we can take negative sign outside. Then partial derivative with respect to y. When you take negative sign outside, we have positive quantity. And according to this one, this is equal to y. Now identify the correct option from here. It is not a twice of this one, so this is incorrect. In this case, it has a positive sign, so it is incorrect. In this case, it has a negative sign, even it has a negative sign. And in C option, we have a partial derivative with respect to x and the coefficient is x. In this case, the coefficient is y. But in our case, we are getting a x. It means the option C is correct, but D is incorrect. Moving towards the third type of a question. In this case, rather than writing a function exactly in form of x and y, the function is of the form ax plus by. Now, we need to evaluate this term. Now, how to evaluate this? Ultimately, this function is depending upon two variables x and y, where a and b are the constant. We need to find the partial derivative of z with respect to x. How to evaluate that? First, we will take the derivative of function. Whatever the function we have, we will take its derivative. And the internal derivative with respect to x. And that will be the partial derivative. this term is equal to derivative of a function into derivative of this one with respect to x is a. Similarly, evaluate the partial derivative with respect to y. We will take its derivative first, then partial derivative of the internal term but with respect to y. This is equal to derivative of a function into b. Now substitute these values over here. We have b times of partial derivative of z with respect to x as a times of first order derivative of a function minus a times of partial derivative of z with respect to y, that is b times of first order derivative of function. This term is equal to 0. In this case, the answer is 0. Now, why we are taking this form? As per this question, the function is not given to you. Suppose the function is given, that is a sine, and this internal term is as it is, then evaluate this term, you will get a 0. In this case, the derivative of function means the derivative of sine, that is a cos of ax plus by. And when you are taking the derivative with respect to x, means we are taking the partial derivative of this internal term, that is a. And when you are taking the derivative with respect to y, means we are taking the derivative of internal term with respect to y, and that is b. I hope now you can connect this function with respect to this example. In this case, we can simplify this. Rather than taking a function of y and u with respect to x and y, we will take a function of y, and in place of u we can write xy. Now ultimately this function is depending upon two variable x and y, and as per the requirement we need a partial derivative of z with respect to x and with respect to y. So first evaluate partial derivative of z with respect to x, that is calculated as derivative of this term with respect to x is 0 plus, in this case it involves the x variable. First we will take the derivative of a function into derivative of internal term with respect to x, and its derivative is 1 by y because y is constant. Similarly, take the partial derivative of z with respect to y. Its derivative with respect to y is 1 plus, now take the derivative of function into derivative of the internal term with respect to y. X is constant in this case. Derivative of 1 by y is minus 1 by y square. Simplified form in this case is 1 minus x by y square into derivative of function. Substitute the values of partial derivative with respect to x and y in this case. So u times of partial derivative of z with respect to x is 1 by y derivative of function plus partial derivative of z with respect to y, that is 1 minus x by y square first order derivative of the function. The value of u is x by y, so we can replace this by x by y. X by y square first order derivative, and this term is also same but they are in a alternative sign. Cancel this one. Finally we have in this case is equal to 1.